Alright, let's take a look at conservation of momentum now. So it turns out that the momentum of the system is going to remain the same or conserved for an isolated system. So conservation of momentum law says that momentum of the system is conserved or if there's no external force, there's no work done on the system, in that case we're going to say that the momentum remains the same. So basically we're talking about isolated system. So according to the statement of conservation of momentum, it says that the momentum before is equal to the momentum after final, so initial momentum is equal to final momentum. So it means that we can apply this to the collisions or things that are colliding with each other in when there's no net force applied from the outside. And it only means that the two objects are interacting with each other. Look at it as a special scenario which we can see that things are separating, exploding, or there's a recoil, or the system is breaking into two systems. In that case, we can idea is similar to the idea that we have seen before for conservation of energy. Like I said before, we had energy in beginning equal to the energy in the end for the also keep in mind momentum will be calculated by taking the product of mass and velocity. So let's take a look at some applications and solve some examples. Let's say we have a clay and it has some mass, 1 kilograms, and it's been thrown with some velocity of 10 meters per second to the right. And then it hits a block or a box that is not moving. It's at rest on the ground or some surface, but it has a mass of 4 kilograms. So now this is what happens before they actually collide. So that's why we're going to look at it as initial. Now, after they have collided with each other, what happens is that let's assume that the clay gets stuck to the block or the box and it starts the system together moves with some velocity. So that's what we're trying to find out. So that's our final scenario. Now we're going to solve this problem by starting with the conservation of momentum equation, which means that for initial momentum, we need to find the momentum of the clay separately and the momentum of the block. So we need the mass and the velocity for each of the object, multiply those numbers, and then add it for if there are two objects in the system. So the momentum for the clay and then momentum of the block or the box. This should be equal to the momentum after they have collided, which means that I need to figure out the mass. So since they're together, I have to simply add the masses of the two objects, and I got 5 kilograms multiplied by the V. The rest is solving the equation and finding the value, solving for the velocity or the velocity of the block and the clay that are moving together with some velocity. So I got a positive answer, which means that they're both going to move in the same direction that I set up as positive. This is an example of inelastic collision, which means that when objects are getting stuck after colliding and become one system, in that case we say this is an inelastic collision. Now let's take a look at another type of collision and solve an example. So let's say we have two objects. Before they're both moving and they have some mass, and let's say the first one is moving with some velocity of 3 meters per second to the east, and the second one block has some mass and some velocity, but at this time in the opposite direction. Now after these two objects have collided, what happens is that, let's say in this scenario, the first object starts moving to the left, or we can say towards west, and it has some velocity which is different, but I don't know how fast is the other object moving. So again, this is an problem that we can solve using conservation of momentum. We need to be careful what east needs to be positive velocity and west needs to be a negative velocity. So when you plug in those numbers and solve the equation, you should be able to find the velocity of the second block, which is 2 kilograms. So it seems like the two objects that are moving with some velocities are colliding or striking, and then the first one is moving the other opposite direction, whereas the second 2 kilogram object is moving with a smaller velocity. Now this is called elastic collision, where they bounce off. Now we're going to look at the third type of scenario. So before the cannon fires the cannonball is sitting inside the cannon, and after it is being fired, the cannonball is getting out from the cannon and moving a certain direction, whereas there is some recoil of the cannon, or it moves backwards, or there is some kickback for the cannon. Now let's solve the recoil of the cannon, how much it is, or the velocity with which it's moving the cannon after firing. So let's say the mass of cannon is 150 kilograms and the cannonball is 5 kilograms, but the cannonball after coming out from the cannon is moving with a much faster velocity, which is 30 meters per second to the north. So we're going to solve this problem using conservation of momentum. Initially, in the beginning, the cannon holding the cannonball is not moving and has no momentum because of no velocity. And then I find the momentum after the cannon has fired the cannonball as separate momentums for the cannon and the momentum for the cannonball. The rest is solving the equation or using math, and you will be able to find the recoil velocity or the kickback velocity of the cannon, which is comes out at -1, which means that it's moving in the opposite direction and confirming that there is some recoil.